untouchables enslaving us as they are on their way. Neil deGrasse Tyson yells out, attesting to the most puzzling and awful disclosure made by the Pioneer in the past 10 years, an exposure that specialists were not the smallest piece prepared for. Since the Pioneer sent back this disturbing data from space, laid-out analysts have been unable to rest, and everyone is walking around in a stressed environment. Experts, scientists, and designers have been mixed from their stations to fight these strange objects that Traveler just spotted. We have no clue about where these surprising things are coming from or where they are going. Yet, what we can rest assured about is that we have seen nothing like them before. What are these confounding articles that were as of late found by Adventurer 1? Join us today as we investigate these reactions in Neil deGrasse Tyson's Pilgrim 1, which has distinguished 500 dark articles passing by in space. For close to 50 years, Wayfarer 1 has been cruising through the streets of space, researching the significant areas that ground-based telescopes have been restricted from seeing and revealing disclosures that leave our mouths totally open in shock. Because of the virtuoso characters that stream in overflow at the Johns Hopkins Applied Physics Laboratory, Wayfarer 1 has been the brilliant courier to the new locales of intergalactic space. This engineering showstopper has awakened us to the superb marvels that exist in our universe. In another advancement, Neil deGrasse Tyson has affirmed that Voyager has recognized 500 dark objects floating tranquilly in space. This news came as a shock to standard scientists, shaking them as everyone began poring over the data gathered by Pioneer 1. Something odd was fermenting not too far off, and it was challenging to settle this frothing question that had dazed even the best of specialists. Since Neil deGrasse Tyson affirmed this revelation, different understandings have been flying in the air, attempting to draw an unmistakable picture that figures out the mystery. Had it been another space apparatus that conveyed the sort of stupefying data that was as of late imparted from space, analysts might have scrutinized the legitimacy of the information. However, it is Voyager 1 we are examining here, the space test that has been cruising through the vast ways of space for nearly 50 years now and has outperformed our expectations. Like a patient who beat malignant growth, Wayfarer 1 has outperformed scientists' anticipated life expectancy of 3 years to spend more than 45 years in space, uncovering history-making revelations. Meanwhile, the most captivating part about this well-known story is that Pioneer is composing this achievement story from a very far distance from Earth. The last time scientists checked, they saw that the space test was 14.5 billion miles from our planet, running ceaselessly in space with no sign that it would lessen its speed anytime in the near future. Researchers say that the space test has been going at a rate on multiple occasions the distance between the Earth and the Sun every year. This is one truth that specialists have found a little difficult to accept, on the grounds that normally, one would have expected the space test speed to have declined altogether given the longevity of its mission in space. Upon closer examination, it appears that Traveler 1 is bound to be the exception to this story, and it has shown proof of this again with its latest revelations. It was just like any other day for scientists when Voyager 1 delivered news that would stick in their memories for a long time. Pilgrim 1 had stumbled upon several unusual objects passing by in space. This exposure was unexpected, which explains the initial confusion among space experts when they investigated data showing that around 500 dark objects had appeared from nowhere. In a brief moment, we went from having no knowledge of these objects to analysts breaking their mental capacity, searching for answers to this puzzle that nature had landed on their laps. Specialists were in a fix, and the fault could be traced to only one party, Wayfarer 1. Suddenly, scientists realized that the solution to unraveling this mystery also lay on the weighty shoulders of the space test. At first, when news of this revelation broke out, some scientists wondered how it was possible that it could have been a mistake. They thought that Pilgrim might initially be finding it and thus might be transmitting wrong data back to us. If we choose to follow this unfolding path, it seems a plausible explanation, given that Traveler 1 was launched as far back as 1977. After almost 50 years of active service for mankind, one might expect the test's computers to have become exhausted, started to mess up, vacillating in their duties, and sending back low-quality data to the ground crew. As engaging as this scenario sounds, analysts have advised that we shouldn't settle there, as it would be a slap to the spirit of the Pioneer. Despite the unforgiving and inconsistent climate of space, Pioneer 1 has consistently produced clever data about our universe. In defiance of the hurried presumptions of cynics, the space test has maintained its long life due to its dual redundant computer systems. Like its twin, Explorer 2, Wayfarer 1 came equipped with two sets of command subsystems: Flight Data Systems, FDS, and Attitude and Articulation Control Systems, ACS. This has been the secret force behind the space apparatus' strong fighting spirit when it comes to navigating through space and revealing discoveries. The overt redundancy allowed for continuous switching between systems and the ability to activate dormant computer parts, thereby preserving their life expectancy. While planning Traveler 1, the specialists on Earth devised a plan to improve the space apparatus efficiency. This expected that the test's instruments would depend on simplified systems, as they were constrained by time requirements and power budget limitations. Electrical engineers concluded that the instruments needed to be created using simplified systems that relied on hardware logic. Thus, Pilgrim's computer systems contain 6 embedded computers integrated as a distributed system, with 3 dual redundant pairs. Having overcome this obstacle, analysts faced the next tall order: maintaining the systems. This daunting level was conquered by devising a continuous power management plan. Here's where it gets interesting. Power management included supporting the operational functions of Explorer's computer systems. To be straightforward, this is a difficult task, given the limited power resources available on board the rocket. It was a case of sending a hunter into the deep wilderness to hunt wild animals with just a handful of tools. Nevertheless, specialists found a way to get around this issue by devising several measures to monitor and advance power use on board the Pioneer. A genuine example of these power management measures that specialists devised is the essential shutdown of non-essential systems. Specialists were compelled to make this difficult decision and used a deliberate approach to identify and deactivate parts or subsystems that are not critical for the shuttle's primary mission objectives. We see evidence of this when we look at heaters associated with certain instruments that had to be switched off. These heaters were initially designed to maintain the instruments at specific temperatures for optimal performance. However, the story had to be adjusted by activating them only when necessary, as it greatly reduced power consumption on board the shuttle. This reduction in the shuttle's power use has a ripple effect. It extends the test's lifespan. This is a win-win situation for everyone. Additionally, we should remember that the decision to shut down unnecessary systems is not taken lightly. Such an action requires careful consideration of the trade-offs between power conservation and the scientific objectives of the shuttle. Whenever such a decision was made, all hands had to be on deck. Specialists and engineers needed to come together and assess the impact of deactivating specific systems on the quality and availability of scientific data. Emotions were not in control. It was all about the facts at hand. The team was driven by the desire to maximize power efficiency while maintaining the essential functionality of the space apparatus so it could continue to gather valuable data about our universe undisturbed. Engineers and specialists alike wanted nothing to prevent Voyager 1 from uncovering the profound secrets locked away in the hidden regions of space. Secrets that the universe has been keeping from us for years. However, unambiguous power reduction is not the only way that NASA specialists are keeping the Pioneer afloat and operating optimally in space. They had another advantage up their sleeves, which they intended to bring to the table to help the shuttle. The specialists devised power management strategies that are adapted to the ever-changing conditions of the shuttle's environment. For instance, as Traveler 1 ventures farther away from the Sun, the available solar energy undergoes a decline. We would agree that this is an issue, but the specialists came prepared. They made up for this growing threat by ensuring that the shuttle adjusted its power consumption accordingly. This adaptive approach is a win for NASA engineers and analysts, as it ensures that the available power resources are efficiently allocated to support the test's critical tasks and data transmission back to Earth. Interestingly, the good news doesn't end here. There have been continuous technical advancements and updates in power management, which have allowed engineers to refine and streamline the shuttle's power system over the years. A close look at these improvements reveals that they include more efficient power distribution, improved battery charging techniques, and advancements in power regulation and control. The implementation of well-thought-out and planned power management strategies has opened an exciting door for engineers. It has made it feasible for them to extend the operational lifespan of Traveler 1 alongside its twin, Explorer 2. This is a significant achievement for standard scientists and the world at large. The careful allocation and management of power resources have given Explorer 1 the crucial resilience needed to continue exploring the depths of the universe. The discovery resounded through the halls of scientific inquiry with seismic force. Neil deGrasse Tyson's earnest announcement reverberated across the globe, emphasizing a decade of meticulous research by Adventurer 1. In the midst of the vast realm of interstellar space, the shuttle had accidentally encountered an